city of Fort Collins, we have two wastewater facilities. The larger one is the 23 million gallons per day Drake Water Reclamation Facility. The smaller one is the 6 MGD Mulberry Water Reclamation Facility.
The Drake Water Reclamation Facility is the main wastewater treatment plant for the city of Fort Collins. It's rated for 23 MGD, and we have primary clarification. As far as secondary treatment, we have an A2O process, and we have 4 digesters and UV for disinfection.
So after the installation of biological nutrient removal in the north and south trains between 2012 and 2015, we were starting to get increased biological nutrient removal, concentrating the phosphorus in the solids. It went to the digesters. So when we dewatered, our orthophosphorus and our ammonia was much higher than before biological nutrient removal. And so we were able to lower the orthophosphorus, or the total phosphorus leaving the plant, but not to the point of our required regulations. With biological nutrient removal, we were able to lower our total phosphorus leaving the plant from approximately 4 milligrams per liter to about, on good days we'd be below 1 milligram per liter, but most of the time we'd be in the 1.5 to 3 milligrams per liter range. So we needed something else to meet the Regulation 85 that Colorado has in place by January of 2021.
Soluble phosphorus concentrations we had would be uptake by the bacteria in our secondary process. We would then waste that to the digesters, which is anaerobic, and we would have release of the phosphorus in the digesters, which would then go into the centrifuges, and the phosphorus remained mostly in the solution, so it would be returned with the centrate back to the head of the plant to be treated back through the same process again. So essentially we weren't removing phosphorus, we were just kind of shifting it around the facility.
We were not going to meet future regulations, so when we started looking at the technologies that would fit into our facility and the way we operate the facility, we chose the MagPrex for being able to capture the solids component of it and the dewatering ability.
We did an analysis of several different types of chemical phosphorus removal. We looked at operating costs, we looked at capital costs, we looked at ease of maintenance, and we actually went over to Europe and analyzed several of those processes. And MagPrex kind of rose to the top as being the simplest system and most cost efficient for our application.
The MagPrex system is a phosphorus removal system. It removes orthophosphate, soluble phosphorus, which is released in the anaerobic digestion process, right after the anaerobic digester and before dewatering. Most technologies either work in the centroid stream post dewatering or in front of the anaerobic digester. MagPrex difference is that we operate post anaerobic digestion but before dewatering, and that is important as we want to remove this soluble phosphorus before it goes to the dewatering equipment, because phosphorus has very negative impacts on dewaterability of your biosolids.
The MagPrex process fits into our footprint very nicely because from our digesters we originally pumped sludge into a sludge holding tank, and which we fed our centrifuges from. And by putting the MagPrex process adjacent to that sludge holding tank, we were able to intercept the sludge, treat the sludge, and then send it by gravity over to the sludge holding tank.
So after the digested sludge runs through the centrifuge, it falls into an auger system that is then conveyed to the back of one of our biosolid trucks. We typically fill the trucks to around 42,000 pounds, and then one of our city personnel drives the truck to Meadow Springs Ranch, which is a 26,000 acre ranch that also acts as a cattle ranch, and they spread the biosolids out there on the pastures year round.
We initially went into this design hoping to do phosphorus harvesting, and because it's a cool thing to do. But as the project developed and looking at our budget, we realized that we weren't going to be able to make that. So what we did was we designed our process, our system, so that we can add it in the future if we decide to do that. So we've been very happy. Our two main things have occurred with regards to phosphorus concentrations. We're getting about 95% removal of our sludge coming from the digesters compared to the sludge that's leaving the MagPrex reactor. And that feeds directly into the centrifuges, which lowers our phosphorus recycle within the plant system. By doing that, our phosphorus concentration in the digesters themselves has almost been cut in half. We originally get in about 450 to 500 milligrams per liter at some point to the centrifuges, and now we're pretty consistently in the 220 to 240 range.
MagPrex is performing really well right now, so I think the recommendation that we got from CNP was about a 90% removal, and we're actually hitting 95, 98% removal on our Ortho P, which is awesome. So it's, as far as I know, it's the best in the state. We are below our 1.0 milligram per liter total phosphorus limit, Reg 85. The phosphorus going into the digesters has been reduced, so we don't have that recycle stream going back through the plant. Our goals are always to reduce chemicals, meet regulations, and do it in a safe manner. And so MagPrex allowed us to achieve those goals. We are regulatory compliant now with MagPrex.